Howdy, Lance.
Good. How you doing?
Good, good. Thanks for being a part of this.
Yo, thanks for having me.
Absolutely. All right. So we are in the second to last session because Zebra has a chat after this session of the day. So home stretch time, folks. I don't have any other announcements, so I will just hand it off to Lance. Let me get your thing here.
Sounds good.
All right. Take it away, sir.
Great. So hello, everybody. So my name is Lance Gleason, and I am an Android developer. I work at a small little company called Polyglot Programming currently. And on top of my Polyglot work, I also do a little bit of writing for RayWonderlick.com, some articles, books, even a little bit of editing here and there. So lots of fun stuff with that. I also am somebody who's really big into the whole pair programming, agile, and TDD type of thing. But with COVID in particular, I think this has brought this to the forefront. But I'll say that I've been doing this for a long time, and that is I'm a big advocate of going beyond just having a human dev pair and substituting that out with a feline dev pair. And so I do a bit of pair programming whenever I can. And for the dog people out there, though, I do also have a dog. And so I started a couple of years ago, going beyond even pair programming and doing a bit of canine coding. So there's my little Shih Tzu there. I started him off as a puppy. And it's added a lot of variety and fun to our team here when I'm doing my work. Here we are with a mob session where we're getting started there, interspecies mobbing. It's something, if you haven't tried, I highly recommend that. But at any rate, of course, we're not here to talk about programming with dogs and cats, so that would be a lot of fun, and it could be a great social thing. We're here to talk about offline sync. So to start off with, I guess the biggest thing, though, is why do we even care about offline sync? You know, why do we do this? And really, the scenario that we're talking about here and why we care about doing it is that it's when you have an app that you're trying to use in some desolate place. And not only desolate, but where there's no internet connectivity. But before we get into all these tips and tricks that you might want to use to help with your offline sync efforts, there's one big question you really should answer, and that is this a need or is this a want? And even if you think you're pretty sure it is something you need, I would encourage you to ask that question again. Are you sure you really need this? Because you're in for a lot of work. But providing it's a need, let's dig into what are some of the things that you might consider while doing that. And to kind of walk you through this, I'm also going to kind of share a little bit of a story about one of my first offline sync projects. And what that happened to be was an application to manage work orders and tasks for construction sites. And when I first got involved in this one, they already had an online-only version of the application. And some of the key workflow of the application was that you could go and you'd bring up one screen and it would show you a list of work orders. And you could tap down into that, and then it would show you, oh, look, there's your detail for the work order along with tasks that you have to do, which are attached to those work orders. And if you dived in, it would dive in a little bit deeper and tap on one of your tasks. You might get some details about that task itself, including notes. You could change the status and do all sorts of interesting things like that with it. The API that went along with that we inherited looked very similar to how the flow of the current UI of the application was. And so in this case, for the work order screen, we had an API that was very much coupled with that. So you had here, you have a get your work orders, and it just returned you work order metadata with nothing else there. So then when you tapped into an individual work order, what would happen is that it would show you additional metadata about that work order, but only what you needed to display that screen. And there happened to also be some task information there as well. So it would show you about, but again, just what you needed for the task so that then you could display that in your list. And then finally, when you needed to go and view more information about the task, like to get notes and some more detailed status information and things like that, we had another request. And that request would, you would get the task, get it by task ID, and it would give you more information. And for an online version of the application, that works pretty well. And, it was a reasonable approach. Some other pieces of functionality this application happened to have, and that we needed to support. And the other key caveat with this is that this application, we already had an online version, but they needed to have offline functionality for it. And that's something I probably didn't say initially, but the point being that you're able to manage work orders, but you can't guarantee internet access. In fact, some sites just don't have it at all. So they needed to be able to have all this functionality offline now. Okay, so you're able to create your work orders. You need to be able to add tasks. You need to be able to update records. But here is a big one. They also stated that we don't have any server-side resources to create additional endpoints. So we need to provide all this functionality, allow the users to create this, or rather use this offline with no additional endpoints. How hard could it be? Now, admitting something here is a fresh, inexperienced person that had not done this before, and this was a few years ago. I actually seriously looked into doing it this way first. All right. So before we start to look into why we're probably going to want to look at something different here, let's look at a few more details about our use cases with this. In addition to having these work orders and all this other stuff with it, on a construction site, each floor of a building can have hundreds of work orders. Each work order has at least 10 tasks, and each building can have multiple floors. Many users that we have, if you look at across our user base that we had for this application, many users, they may have needed data for multiple buildings. And many users also may be working on the same work order. So you could have scenarios where you have multiple users that may both be offline that need to work on the same work order. Okay. So first thing I did when I got into this application is I started to crunch the numbers. And we took a kind of a common scenario, which was an average user would have a construction site that had roughly about 3 buildings, and each building had about 2 stories. These are just some rough back of the napkin. And when we did the math, we kind of ran into the following. 3 buildings times 2 stories times 100 work orders times 10 tasks means that to sync all this data locally, we would need to have made 6,000 requests. That's a lot of requests and probably not a good idea. And that brings us to tip number 1. If you have to do offline sync, you may get lucky and have endpoints that will actually work for it, but you probably are going to need to create separate endpoints to support that online sync effort. So that's the first thing you're going to want to do. Now, looking at this endpoint again, and more importantly, looking at our data, that was really the biggest issue with this, with our current API, with the API we had previously. This is what we ended up with. We ended up with something like this, where we had a get. So we saw the get request, and we were still returning work orders, but now we were providing all the data for the work order along with the tasks, and that reduced our 6,000 requests down to 1 request. Definitely an improvement. That being said, though, one key thing you have to look at when you're doing offline sync is it's kind of the best analogy I could come up with for this is it's kind of like when you're packing for a trip, where when people think of offline sync, they quite often, especially a lot of business people and stuff like that, they'll be like, well, okay, yes, we really need to take care of one scenario, like an electrician, for example, may only need things that are related to electrical, but they may need to look at this and they may need to look at that. And it's kind of like packing for a trip where I need to go to Chicago for a weekend. I live in Atlanta. And let's say it's this time of year. Well, what I really need is I just need a couple of changes of clothes, maybe a light jacket, some shoes, and maybe my laptop. But I could say, well, but maybe I'm going to want to go swimming in the lake. So I probably got to bring my snorkel and my flippers, and maybe, I don't know, maybe I want to go play some baseball. So should I bring my baseball bat? And before you know, you just have like all this extra stuff. And I probably should bring 10 changes of clothes because who knows, maybe I want to go out someplace different. And you end up with a scenario like this. And the point is, in the end, though, you're really just looking for, you just want to pack what you need. That's really tip number 2. Travel light and only store the data that you need. So in this case of this application, some things we looked at: limiting by job function, electrical versus carpentry, assign work orders or tasks, and only sync those items that are assigned to somebody, because there was a concept of assigning things to a user. There's also the idea of syncing all high-level work order data. And we actually looked into all 3 of these, and we ended up kind of doing a hybrid in the end. But where you could sync all the high-level work order data, but then only grab the details on stuff based on somebody's job function or assignment. Because we only had hundreds of work orders, but we have thousands of tasks. Okay. So now that you have your data and you have an initial sync of that data down, what's usually going to happen is at some point, you're going to have to update that. Things on the server are going to change. Some user added something somewhere. So how do you deal with that? Well, one approach could be that you delete everything and re-download everything. And that can work. On the plus side, it takes a lot less development effort. In fact, it's a very simple way to do it most of the time. But it does have a few drawbacks. One of them being that in the case of like our work order management system, if you've got roughly about 6,000 requests we would have had to have done before compressing that data, it's thousands of different records that we're storing somewhere, which means a pretty big JSON file. Your data update as a result of that might take longer, and having such a big data set like that can create interesting scenarios when you run into later on, or rather if you do, depending on the application. But in this case, we had a need to also be able to do uploads back to the server. So when we look at all those things, how do we deal with that? Okay. One approach, so the other way we can deal with that is we can only update modified records instead. Updating only modified records consumes less data, can allow for optimizations if you need to post data, gives you faster data updates. Okay, so tools now. We've talked so far about updating our local data. We've also talked about getting that initial sync down. And there are a few different tools that you can use to store that data. And I'm not going to get into some of the things like, for example, what if we have a, one of the classic examples is like, what if we have, our network layer, different things like that. We're not going to worry about that part. Let's worry instead about what are we going to do with our actual data store? Because that's usually the biggest question is, how are you going to store that data locally on your device? One very simple approach you can use in certain circumstances is just file storage. If you're dealing with things like photos or videos or something like that, you might be combining that with some other form of more structured data storage. A key value type of store might be another way that you could locally store that data. A very simple scenario, and one that I usually wouldn't recommend, but you can use it from time to time, is shared preferences. That being said, for most case, if your case has any amount of complexity or any reasonable amount of data, that's probably not a great thing to use. So probably a better option might be to use Firebase or Couch or something like that. In the case of this application that I was working on, and really most of the applications I've worked on, we usually ended up going to some sort of a relational structured type of approach. Um, and probably two of the biggest options these days, RoomDB, which is backed by SQLite when you're really getting down to things, and Realm. And I would say that probably earlier on, I was using more Realm, but later on, I've moved most projects and gone with just RoomDB. There are pros and cons to it, and that's a whole nother discussion. You could probably have a whole talk on that. Which brings us to tip number 3. If you've got simple scenarios, use unstructured data. And if as they get more complex or they lend themselves to being more structured, then you probably are going to want to go to a more complex scenario. Okay, so background syncing. Yes, you can do data syncing without doing things in the background. However, most cases, you're going to want to have some sort of a service that syncs things while you're doing other things in the application, or even not running your application at all. And there are a few different ways you can do it. You can wire things together and all that, but probably what I found in more recent times with this is that if you can use Jetpack, the Jetpack Work Manager makes life a lot easier. Which brings us to tip number 4. If you're going to do background syncing, which you probably will, try to use Jetpack Work Manager. Of course, I did it as a Dos Equis, but... So now that we've figured out the basic things about how to bring our data down and some ideas on how we can manage our updates. And should we do them by record? Should we do them in a more granular approach? What's the best way to do that? But there's another key thing that we also have to figure out, which is how do we let our application know that we need to be able to do an update? And there are a couple of big methods or big mechanisms that usually, I'm going to kind of bundle them together is the best way to put it. So one mechanism that you might use is polling. And if you're limited by things like you can't use push notifications or you can't do something else like that, then you're probably going to use polling. And polling is just, it's your application, you're running something in the background, occasionally checking in with the service at some time interval, and seeing if there's new data available. A better approach, though, is to use, in my opinion at least, is to use silent push notifications. And this is what I've usually, sometimes I've had to go with polling because we had IT limitations for a client or something else like that. But when we haven't had those limitations, we ended up going to silent push notifications. And what that is, in essence, is that first, to understand silent, let's talk about push notifications. And so a push notification it's a notification that you're sending to your device. But the way that it works is that you register your device with your backend service. You then go and on that backend service, now that it has your device registered so it knows its unique identifier, that service can then contact either directly, it can contact Firebase or Google, or it can contact Google through like some third-party vendor, such as you could use the Amazon service or something like that. And when it wants to send a notification, it contacts that service with your unique identifier and a message. And then that message will be displayed on your device like this picture here. A silent push notification uses that same delivery mechanism, but without displaying that message. And what that allows you to do is you can put metadata inside of that push notification to tell it to do something to bring your app up. Your app can be looking for it, and then it'll bring up your app. And you can even send it a little bit of metadata along the way if you want to. And where that becomes extremely handy is now you're not having to constantly pull and create all that extra traffic for the server, nor are you having to create extra traffic on your for the clients. Instead, you're only getting updates when something that's important to a specific user needs to be updated. And that's tip number 5. When possible, use silent push notifications for triggering updates. It usually, especially if you have any form of complex data updates where you have where some users may have a lot and some may have a little, it can add a lot of optimization to the process. Okay, so let's talk about primary keys. Going back to our example here, and I've seen this happen on some projects. So imagine if we have our offline work orders request here, and in our work orders request, we're returning all the data that we need. And in this case, we have our entire work order, but then we also have these tasks that come back. The tasks are under the work order, so we know they're associated with that work order, but each task does not have its own unique ID. And the challenge that we could run into, there's a couple of challenges that we can run into with that. To kind of fully understand that, let's take the scenario that I've run into on other projects where, okay, I'm going to model this with a relational data store, and I'm going to do it in room. And so if we break that down into room, you're going to have an entity, and your primary key for the work order, it's pretty easy to do because you have an ID under the work order. But for your task, you've got to figure out some way to uniquely identify that record. And you end up just creating, like what I've often had to do in certain circumstances is you create an ID, you call it a primary key, but you're having to do an auto generate on it and maintain that key, unique key information just on your local data store, but there's no relationship between that and what's up on the server. The challenge with that is that you have no way of then, if you want to update some tasks under a work order, the only way you can do it is have the server pretty much just update, blow away all the tasks that were originally there and replace it with what the client had. And there's no way to do granular updating. So if, let's say you have different users that may be editing different items or something else like that, that can become really problematic. And so an optimization, and something that I usually end up doing on any projects like that, is I push for having the API designed in such a way where ultimately, if you just look at the architecture, you want to have your server sort of maintaining, being the source of truth. And the system of record, as you will, for the data that you're eventually going to store there. And so as part of that, it's better to have the server maintain unique IDs for that, so that then the server can identify that if you need to do an update or if it needs to do it, and for anything in that scenario. Which brings us up to tip number 6. It's better to have the server manage unique entity keys for record updating. If you're having to manage them locally and you're modeling the data relationally, it definitely can be a smell. Now, yes, there are a few caveats with that, because it could be that your server, for example, maybe they're using a NoSQL solution to store things on the back end. And, you know, maybe that'll work for them. I mean, there are a lot of other moving parts, but quite often still, I think with a lot of applications, your local data lends itself to being relational, and quite often the server side does as well. And so as much as you don't want to have things too tightly coupled, that is one that makes sense from an architectural standpoint. And the other advantage of that too is iOS can also leverage that, because in a lot of applications I'm sure that people are working on, yes, sometimes it's only Android, but quite often they can also be iOS as well. Okay, pushing data to the server. We've talked so far about bringing our data down. We've talked about uploading our local data. But at some point, we're going to need to push that data back up to a server. And there are a number of questions you're going to have to answer. Do you want to push all local records? Do you push only updated records? What should that granularity of those pushes be? And really, the answer is it depends. But I'll leave one tip with this one, which is what I usually end up doing. Sometimes I have to go more granular because of different reasons. Either it makes sense because of how people are working on the records, or other scenarios like that. But try to update as coarsely as you can to avoid complexity, because the more complexity you add, the more scope you add to the project. And the more scope, and also there's a lot of other scenarios you run into at that point, because it's more complexity equals more ways for it to break and all sorts of things like that. Collisions. And with collisions, what I'm referring to is, imagine this scenario. It's 1 o'clock, and at 1 o'clock, a user who has a fresh data sync goes offline, and they use their application offline for an hour. During that hour, they make some edits to a work order and some tasks under that work order. At the same time, a user that is online also makes some edits to either the work order and or the tasks. Now, this user that was offline goes back online. How do you deal with that? There are a lot of different strategies for this. There's everything from last in wins, first in wins. You could do some crazy merges. You could reject the offline sync entirely, at least for that record. But there's probably one rule that I would say makes your life the easiest, and probably is the best from an architectural standpoint, thinking about things beyond your application. And that is to let the server manage that. The app should just send it up, get its new data. But any merging, any collisions and all that, yes, there are times when you may need to alert the user or do some other intervention, but generally speaking, you're going to save a lot of work if you let the server primarily manage how to deal with data collisions like that. Okay, so now that we've talked about how to get our data up, how to deal with collisions, how to sync it down, there's one other thing that we need to consider when you're doing offline sync, and that is, how do you clean up for yourself, or how do you clean up data, and what data should you clean up so that you don't run out of local storage on your devices? Again, there are different philosophies behind this. You could use unused records. Common ones are also things like taking the oldest records and deleting them after a period of time. You could also do something where you say, if your local storage gets X number of records, look for the oldest and delete them. You could do something like that. I'm not going to go into detail with that because that could probably, again, be another talk. But I think the biggest thing to take away from that is don't forget to clean up. That becomes even more of an issue if you're working with things like movies or photos or something else like that. All right. And so one other thing. What about offline first? So you probably have heard of that. And offline first is kind of an interesting use case where you have, with offline first, it's a form of caching. And it allows you to, and what you're doing with offline first is you're using like a repository pattern. And instead of with offline first syncing up data where you're, or rather, instead of doing some crazy sync up thing, or rather, instead of reading your data from a web service, you're saying, okay, I want to make some web service requests, but instead of presenting that data directly from the web service, I'm going to store that data first. And then I'm going to access that data from the data store. It provides a form of caching, and it allows you to get some offline functionality. However, it's not really truly an offline sync style type of thing. And it's because, for example, you're only going to be caching data that the user has already accessed. And often in many offline sync scenarios, there's data that you're currently using, but what happens if you're not currently using the application? But you need to get new data because you're like, for example, with the case of the work order management, you have somebody who's all day out on site and they're working on site, and the only time they're going to have connectivity is when they're not using the application, or they're not going to have time to go in and look at every record that they did after the fact. And you run into a lot of scenarios like that. And so really from that standpoint, it's a different form, and it could be its own talk in itself. So wrapping things up, we have 9 tips. Create separate offline sync endpoints, travel light, and only store the data you need. Unstructured for simple and structured relational for more complex, generally speaking, or data that lends itself to that. If you're going to use a background service of some sort and you can use Jetpack, Work Manager will make your life easier. When possible, silent push notifications can add a lot of optimizations to your data usage and other things like that. It's better to have a server manage unique entity keys for records, especially across an entire system. Try to update as coarsely as you can to avoid complexity, but sometimes you can't. It's better to let the server manage data collisions than the application. Again, though there are times you have to, but what I found is it's better when you can to do that. And don't forget to clean up after yourself. But the other big thing with all this is that, while I've just gone over a few different tips with this one and some things that I found while I've been doing offline sync in my own applications, offline sync is hard. And probably the biggest takeaway I had from this was that I severely underestimated how long it would take when I first walked into the project on my first offline sync. And so you definitely, it's a hard problem to solve. It's not easy. And there are a lot of solutions and there are a lot of ways to shoot yourself in the foot. But hopefully, at least, some of these tips will help you to wrangle your offline sync and be the boss of it. So with that being said, I'm a little bit early, but that's what I have for this. So there we go.
Awesome. Thank you, sir.
Yes.
Hard to go wrong with cats, although you breezed right past the cat burrito one really quickly. I was a little bit bummed.
The kitty burrito, yes. And that, by the way, is my cat, by the way, too. So.
Oh, very dapper.
Yeah.
Let's see. All right. See if anyone types any questions for a second.
Okay.
Otherwise, thank you very much for being a part of this again. That was a great talk. Oh, we do have a question.
There we go.
What do you do if a device misses one or more of those new data on the server push notifications?
Push notifications could definitely be one option. I mean, that's definitely, either, it could be push notifications. That's one approach you could take. It could also be, timestamps could be your other way of determining that as well. Whether you miss getting certain pieces of data on one device or multiples, actually either one of those could do. But yeah, push notifications could certainly be a mechanism for that, because with push notifications, you're going to have to register each unique device. And so on the server side, they could then implement that so that it tracks and knows, okay, these updates made it to this device, but we still need to push these updates to the other device or something like that. Actually, as I think about that, you wouldn't even need to do that per se, because each push notification would have its ID. And if you're managing that correctly, you could just be like, okay, this is push notification, such ID, and this means you need this data versus the other two. Different ways you could do it, but yeah, that would something like that.
Nice. All right, we've got one more person typing, so we'll vamp for another minute or so.
All right.
Is that the only outfit the cat has?
She has a few others. I actually do have there's a Christmas hat that she has that she'll wear sometimes.
I feel like that is pretty impressive. I have 2 dogs, and dressing them is fairly easy. I don't know that I could dress a cat.
She's a very tolerant cat. That's
Yeah.
part of the other thing with it too. She's actually very tolerant. The vet loves her because like most cats like will scratch if they try to do things with her, and Allie just will sit there and she head bonks them, and she's really she's great.
Nice. Nice. All right, we got one question from Grant with Yum. How do you feel about eventually consistent models like Couchbase or Realm? They keep track of the out of sync state. My internet cut out and I may have missed that part of your talk.
Yeah, so I really didn't discuss that directly per se with that. I mean, in a way, offline sync is it is kind of eventual consistency, so to speak. Probably the biggest piece with it. I mean, in a way, I guess I'm probably talking about that with dealing with data collisions when you're coming back, because I mean, with eventual consistency, you've got, you have a new update that's going to the record, but you obviously don't have that transactional, like we know, and it has all the ACID properties of a normal, relational type of a model with that. And, I'm not sure if I have a strong feeling one way or the other than it's another way you could approach it.
Gotcha. All right. Well, with that, I think we will sign off. If there are any further questions, just keep asking them in the Slack channel, and Lance can answer them as he sees them, and you can keep interacting with him there. Starting now is the Zebra Technologies Enterprise Android chat. It's just kind of an informal roundtable discussion. So if you do Enterprise Android or are curious about it or any of the in-betweens there, hop into that. If you go and hop in just down the sidebar there to sessions, you'll see it as an option. You can just click right in and join the conversation. Remember, tomorrow we start at 11 a.m., not Mountain Time, not 12, because we had to move Wojciech's talk from today. So he will be here tomorrow. So we are not missing out on some content. We're just going to start an hour earlier than originally scheduled. Hopin is up to date. The website is up to date. So with that, thank you, Lance, so much for being a part of this and closing us out for day 2. I hope everyone has a good rest of the day, enjoys their chat with Zebra if they do it. Otherwise, see you all tomorrow.
Sounds good.